All right. Good times. You know, I just no, I was able to anticipate it at least. That I wasn't able to anticipate. Okay. So, no more apples, right? Well, this is our mission over the course of next week. You see somebody throw an apple, let me know. All right. Let's look at the way we want to represent this final answer. We got 2 times 4 minus x to the fourth minus 8x times 4 minus x to the third. The question is that there's actually a better way to write this answer. You can factor out a 2 and 4 minus x to the third. Look what I can factor out. What am I left with right here? These both have a factor of 2. These both have a factor of 4 minus x to the third. I'm left with 4 minus x from here, minus 4x there. Can you combine terms here? You okay? All right. So what is 4 minus x minus 4x? 4 minus 5x. Now, as you have that, can you distribute the 2 through the 4 minus x? No, but can you distribute it through the 4 minus 5x? Yes, so we've got 8 minus 10x times 4 minus x to the third power. That's a better way to write it. That's what you should do. What? 2x. What? Wait a minute. Oh, yeah, because I took 2 times 4 and 2 times 5. Yeah. Yeah. Yep. Yeah, I want that. That's what I want. Okay? You got it? Woo, there it goes. Yep, put the 2 back in. Got it? All right, next one. Let's think about this. Give me a value for x. 3. Take 3, plug it in. You take 3 times 3. After you take 3 times 3, what do you then do? Then you take the sine of it, and after you take sine of it, then you square it. So this is actually sine of 3x, that quantity, whatever that is, squared. That's what that means. So as you put something in, what's the last operation that you do? You square it. And so that requires the use of the chain rule. So we set up the chain rule. The last thing we do is square it. So the outside is going to be u squared. What is it that you square? Sine of 3x. What's the derivative of u squared? 2u. How do I find the derivative of sine of 3x? I use the chain rule again. This is a double chain rule problem. Sine of u, 3x. What's the derivative of sine of u? Cosine of u, positive. Derivative of 3x, 3. Plug that back in, so I get 3 cosine of 3x. That's that derivative. That's why I told you guys you could sit wherever you want. So then no, I don't want you over there. I don't want you over there or in the back. I want you in this vicinity. Okay, so we multiply them together, and we've got 2 times the sine of 3x times 3 times the cosine of 3x. Should I leave my answer like this? No, what should I do? 2 times 3 is 6. 6 sine of 3x, cosine of 3x. That's the answer. That's the derivative. Not too bad. Remember, in order to find the derivative of sine the other day, we had to use, that sandwich theorem. That was pretty involved. And so imagine having to do it for something like that. Pretty absurd. Okay, flip it over. 2 more problems. That's all we'll get through. We're going to skip these top ones because you already know how to do that. We practiced that many times already. So we're going to do A and B. That's all we're going to have time for. So these involve more than one rule. So problem number, or letter A, does this require what? Product rule? Very good. Along with the chain rule. So what do I set up first? Do I set up the chain rule first? Or do I set up the product rule first? So this is F. This is G. So we've got F prime G plus FG prime, or G prime F, however you want to write it. It's commutative, so I can switch those. So what's F prime? Negative 6x times the cosine of 4x plus, what's F? What's F? Negative 3x squared. And then the derivative of cosine of 4x, I need to use the chain rule. Very good. Negative 4 sine of 4x. If you set up the chain rule, that's what you should get. Derivative of the inside times the derivative of the outside with the inside left alone. So what I get here is negative 6x cosine of 4x plus 12x squared sine of 4x. Let me see what's going on. Okay, this is the last problem we'll do today. This you might have to go into extra space for, or you might have to attach a sheet of paper. We won't be able to fit C and D in here, I know that. So we'll just do our best with what we got. But we want to take this derivative. Can you identify what 2 rules are needed here? Quotient and chain. Which one do I set up first? Chain, and this is why. When you plug in a value for x, you'll evaluate the numerator, then the denominator, then you'll divide them, and after you divide them, then you will take it to the 1/2 power, right? So seeing how the power was at the end, that's what we're going to use the chain rule for, and the quotient rule came before. We're going to set up the outermost structure first, which is the quotient, or the chain, yes. No, no. If I had this, if I had something of this nature, 3x times sine of 4x, and I had that squared, you would have the chain rule set up and the product rule on the inside. So, okay, so this right here, what I'm going to do in this situation is I will set up the chain rule. And the chain rule, I will have u to the 1/2, and then what's the inside? Minus x over 2x plus 3. Have you memorized the derivative of u to the 1/2 yet? 1/2 u to the negative 1/2, which is 1 over 2 roots of u. In order to find the derivative of 2 minus x divided by 2x plus 3, what do I have to do? The quotient rule. So therefore, I have, if I treat this as f and this is g, I have f prime g minus g prime f all over g squared. So f prime would be negative 1 times g, negative 2x minus 3. Minus What's g prime? 2. So I'm going to take 2 times the top and get 4 minus 2x. All over the bottom squared. Okay. Negative 2x minus the negative 2x. Cancels out. Negative 3 minus 4. Negative 7. So I have negative 7 over 2x plus 3, that quantity squared. Say it. Now, I'm going to multiply these together, and you guys are going to get angry. Because it just ends up really icky. I've got to take this and plug that back in here, right? So I'm going to have a fraction in the denominator. So a fraction in the denominator is a complex fraction, isn't it? So I'm going to set this up as a complex fraction, 1 over 1 divided by 2 times the root of 2 minus x over 2x plus 3 times negative 7 over 2x plus 3, that quantity squared. Told you guys would get angry. Okay, I'm just going to... So I'm going to rewrite this. I could take the square of the top and the square of the bottom, right? So I've got now 1 over 1 all over 2 times 2 minus x to the 1/2 over 2x plus 3 to the 1/2 times that negative 7 over 2x plus 3 squared. Okay with that? So now I have a complex fraction. In order to simplify that, I multiply by the... So that will just give me 2x plus 3 to the 1/2 over 2 times 2 minus x to the 1/2 times negative 7 over 2x plus 3 squared. So what do you notice is going to happen here? I don't have a complete cancel, but what do I... Because I multiplied by the reciprocal. 2x plus 3 and 2x plus 3, right? So what can you do to the exponents? Subtract. So what is 2 minus a half? 1.5, otherwise known as 3/2. Very good. So I have a negative 7 on top. I have a 2 on bottom. I have a 2 minus x to the 1/2, or you could write that square root, I guess. Square root of 2 minus x. And then we have this 2x plus 3. That's going to be to the 3/2 power. And that's the derivative. That's the final answer. So my question for you is, that last one's tough, isn't it? So I have for you an assignment. I will admit that that problem's a little bit involved, but you should be able to practice it enough that if you see it again, it's not as involved. But you are going to have a couple of difficult derivatives to find. You should be able to, I mean, like I said, when we get done with this course, you should be able to take the derivative of anything that you see, anything. And that's going to prepare you for Calc 2. So that's the assignment. And you're going to have time to work tomorrow in class. I told you that, right? and then we will finish up chain rule stuff on probably on Monday. Sometime I got to create the worksheet so we can get back to one day of the sandwich theorem again. And then it looks like we will not test next week, but at the beginning of the following week. You'll have enough. You got to stay on top of your homework right now, guys. It's going to just continue to build. This is a big unit. Big unit.